So I wanted to make a video with the examples that are in section 11.4, just the examples, not interspersed with the text. So that's what I'm going to do here. So the first example is right after the formal definition of the tangent line slope. So there's an example A that says g of x is 1 minus 2x squared, and at x equals -1, we want the slope of the tangent line. So this is a multi-step process. You can combine some steps if you're confident and comfortable doing that. I'm going to do it step by step. So I need g of a plus h. So I put a plus h everywhere x is. So that's going to be 1 minus 2 times a squared plus 2ah plus h squared, because we've done this a lot of times now. And then we're going to distribute the -2, so 1 minus -2a squared minus 4ah minus 2h squared. So that's step 1. Step 2 is do the difference, g of a plus h minus g of a. So if g of x is 1 minus 2x squared, g of a is 1 minus 2a squared. So I'm going to copy my g of a plus h, 1 minus 2a squared, minus 4ah minus 2h squared minus, and make sure you put this parenthesis, 1 minus 2a squared, which is g of a. So now I'm going to simplify. 1 minus 2a squared minus 4ah minus 2h squared minus 1 plus 2a squared. So the 1's cancel, the 2a squareds cancel. I'm left with minus 4ah minus 2h squared. Then the next step is to divide this by h. So you take step 2's result and divide it by h. So I'm going to factor out h and divide by h, so the h's will cancel. And I have -4a minus 2h. So at this point, what I have is called the difference quotient. And then the next step is to do the limit as h goes to 0 of the result from step 3. So that's of -4a minus 2h. So that's going to be -4a. Then the very last step is when, and this was when x is -1. So it's when x or a is -1, whichever variable you're using, doesn't matter which one you call it. So -4 times -1 equals 4, and this is m, the slope of the tangent line. So later in the notes, it asks you to find the equation of the tangent line. So this is the slope of the tangent line. So now let's talk about the equation of the tangent line. So that needs to be an equation of a line. So you need a y-coordinate of the point when x is -1. So you need to find g of -1. So you plug that into the function. Because what's happening here is this is the point where the tangent line and the graph of g touch, is at this point. So it's on both things, the curve and the tangent straight line. So this is going to be -1. So the point -1, -1 is my point that I know is on the tangent line. And so I can write the equation of the line as y minus -1 equals m, which is 4, times x minus -1. And if you want to write it in y equals mx plus b form, which the answers in the back of the book always do, so you're going to have 4x plus 1. Let's distribute the 4, get 4x plus 4 on the right, subtract 1, and get y equals 4x plus 3. So this is the equation of the tangent line to the function g of x. Let me make that 4 look better. At the point where x is -1. Okay, so that's the first example. So then I wanted to do one of the really tough ones for you. So when there's an x in the denominator, that one's a lot more challenging. So we have our function, and we decided to call this capital H because otherwise it gets confusing with too many H's. And we want to know what's the equation of the tangent line when x is 3. So I need h of a plus little h. So that's the step where you don't think very hard. Then step 2 is subtract your function evaluated at a. And here's what's tough about these is you have to get a common denominator. So the common denominator is going to be a times a plus h. They don't have anything else in common. So I'm going to multiply the first fraction by a over a, and the second fraction by a plus h over a plus h. Then I combine them over one denominator, and the 7a's will cancel. So that's step 2, simplified as much as possible. Then step 3 is divide by h. So I'm going to have negative 7h over a times a plus h divided by h. Well, remember that dividing by h is the same thing as multiplying by 1 over h, and that's going to cause the h in the numerator to cancel. So this is my difference quotient. Then step 4 is take the limit as h goes to 0 of negative 7 over a times a plus h. And this is where the error is in the original lecture video. My apologies. So h goes to 0, and you're going to have negative 7 over a squared. So this is for any value of a. And then the last step is when x or a is 3, we'll have negative 7 over 3 squared, or negative 7/9. So this is m, the slope of the tangent line. Okay, so now we need the y coordinate of the point when x is 3. So that's going to be the function evaluated at 3, which is going to be 7/3. So we have the point 3, 7/3 on the graph of capital H and on the tangent line. So the equation of the line is going to be y minus 7/3 equals the slope negative 7/9 times x minus 3. So if we want to make that into slope-intercept form, we're going to distribute the negative 7/9 and add 7/3 to both sides. So you'll have y equals negative 7/9 x plus 14/3. So this is the equation of the tangent line to the function at the point when x is 3. Okay, so I want to do one more, and this is C, where we have the function 5 times the square root of x, and I want to know what's happening when x is 9. So we do our step by step. G of a plus h is going to be 5 times the square root of a plus h. So don't think very hard about that one step. Then we're going to do the difference, g of a plus h minus g of a. So 5 times the square root of a plus h minus 5 times the square root of a. Well, now when we do the divide by h, If I did the limit as h went to 0 right now, I would get 0 over 0. So this is that scenario that we practiced in 11.1, where you have to multiply the top and bottom by the conjugate of the numerator. So we call it rationalizing the numerator. Okay, so we have 5 times 5 is 25. Square root of a plus h times the square root of a plus h is a plus h. Then the whole point of multiplying by the conjugate is that the inners and outers cancel. And then you're going to have minus 25, and the square root of a times the square root of a is a. Then you're going to have a big old denominator of h times, in parentheses, 5a plus h plus 5 square root of a. And let's simplify as much as we can. We have 25a plus 25h minus 25a in the denominator, and an h. I said denominator when I meant numerator. So the 25a minus 25a, those are going to cancel, and then you can see that you have an h in the top and the bottom. So those h's are going to cancel, and I'm going to have 25 over 5 square root of a plus h plus 5 square root of a. So that was kind of, well, that was step 3. So then step 4 is going to be find the limit as h goes to 0 of 25 over 5 square root of a plus h plus 5 square root of a. So this h is going to 0. And I'm going to have 25 over 5 square roots of a plus 5 more square roots of a is 10 square roots of a. And then we should reduce 25 over 10, dividing them each by 5, and get 5 over 2 times the square root of a. So this is the derivative. This is the slope of the tangent line. This is the instantaneous rate of change. So in this problem, we want to know what's going on at x equals 9. So we're going to 5 over 2 square root of 9. 5 over 2 times 3. So 5/6 is m, the slope of the tangent line. Then I need to find the y-coordinate of the point when x equals 9. So that's going to be g of 9. So it's 5 times the square root of 9, or 5 times 3, which is 15. So the point 9, 15 is on the graph of G and the tangent line. It's the point where they touch. Okay, so then we can use the point slope form and say y minus 15 equals 5/6 times x minus 9. Distribute the 5/6. See, that's going to be minus 15 halves, add 15, add 15, and get y equals 5/6x plus 15 halves. So that's the equation of the tangent line to this graph at the point when x equals 9. So be sure and ask lots of questions. This is a super essential part of calculus learning.